The next question on the board, student, is solve and give answer up to 3 significant figures. The previous question we saw was of 2 significant figures, and now it deals with 3 significant figures. Remaining all the things are same. It's a quadratic. This question was asked in the year 2014. I do not randomly select the years and randomly select the questions. I select the questions which is typical as compared to the past years or the current years. So the most typical one, what I feel, which can be nicely explained to you all, I select those questions. So this is from 2014, this question. Let's start, students. In solution, what I write first, I'll copy x minus 1 the whole square, okay, minus 3x plus 4 is equal to 0. First of all, tell me, students, one thing. Does this looks like a quadratic? Quadratic is what? X square, ax square, x पे square होता है. But here I can see I have a square on the entire bracket. No, so first we have to evaluate it. Therefore, it's like a minus b. A is x and b is 1. A minus b the whole square. A square minus 2ab plus b square. A square means x square minus 2ab. 2 into x into 1. So it becomes 2x plus b square. 1 ka square, which is 1, minus 3x plus 4 is equal to 0. Therefore, x square as it is x square. See, here I have minus 2x and here I have minus 3x. Minus 2x and minus 3x is minus 5x. And here I have plus 1 and here I have plus 4. So it's plus 5 is equal to 0. Great. So this is a quadratic. This is a required quadratic. Okay. So now what's the step? Comparing. Yes. Comparing with ax square plus bx plus c equal to 0. Therefore, a is nothing but the coefficient of x square. So a, when there is nothing in front of x square, there is always 1. So a is 1. B is the coefficient of x. Don't say 5, it is minus 5. And the constant c is plus 5 over here. Great. So can I say I got all the values? My value of a is 1, b is minus 5, and the value of c is 5. Now what's my first step? As always, what I do? First I find the discriminant, which is called as b square minus 4ac. B square, what's the value of b? B is minus 5. So I'll write here minus 5 the whole square. Minus, I write as it is minus. 4, I write as it is 4. A is 1 for me. C is like 5 for me. I don't have place, that's why I'm going on the right hand side. Minus 5 ka square, it is plus 25. I can see only one minus sign over here, so it will remain as it is minus. 5 4s are, it's 20. 25 minus 20, it's 5. Great, I got the value of b square minus 4ac. Now let's apply the formula. What's my formula? X is equal to minus b plus minus root of b square minus 4ac the whole upon 2a. Students, I don't have place. You have to do vertically. I am doing it horizontally. Okay. X is equal to minus, this minus is formula's minus, so minus will remain. B, what's my value of b? My value of b is minus 5. So I'll write here in the bracket minus 5. Plus minus, I'll write as it is plus minus. Square root, so I'll write a square root. B square minus 4ac, yes, I know the value of b square minus 4ac is 5. So I'll just write 5 the whole upon 2a. 2, what's the value of a? A is 1, so I'll just write in the bracket 1. Great, great. Okay, therefore x is equal to minus into minus 5 becomes plus 5 plus minus root 5. I'll write root 5 as it is root 5 the whole upon 2 ones are 2. Okay, now 5 as it is 5 plus minus as it is plus minus. Okay, 2 as it is 2 root 5. Now square root of 5 you can see on the screen. Square root of 5 we can obtain from the square root table. It's nothing but 2.236. 2.236. Okay, fine. So now students, therefore what I'll say, x is equal to 5 plus 2.236 the whole upon 2. What I did, it was plus minus, I just took plus over here. Okay, and on the right hand side I'll take the minus one. X is equal to 5, I'll just take minus 2.236 the whole upon 2. Great, great. Okay. Now it's very simple, students. Therefore, x is equal to 5 plus this number. 5 plus 2 becomes 7. So 7.236 the whole upon 2. And over here, x is equal to 5 minus 2.236. If you deduct 2.236 from 5, you will get the answer as 2.764 the whole upon 2. Okay, great. Now let's divide. Pay attention here. 2 ones are 2 3s are is 6, decimal point, carry 1. 2 6s are 12. 2 ones are 2, it's 3, so carry 1. 2 8s are 16. And over here 2 ones are, and it will be 2 ones are 2, decimal point. 2 3s are is 6, it's 7 here, so carry 1. 2 8s are is 16. And 2 2s are is 4. Okay, okay. So can I say one of my answers is x is equal to 3.618. And my other answer is x is equal to 1.382. X is 3.618 and x is 1.382. But pay attention here, students. Please pay attention. 3 significant figures. Significant figures starts from a non-zero term. They do not start from decimals. So we'll start from 3. So 3, it will be first significant figure, 6 will be second, and 1 will be the third. So our significant figures will be this 3. But as I say, just ahead of our significant figures, if we have 5 or a number more than 5, then 1 will be added to the preceding digit. There will be plus 1. We'll have to do plus 1 to the preceding digit. So it's 1. So 1 plus 1 will be 2. And same here, we should have 3 significant figures. So 1, 2 and 3. But this number just after our significant figures, it's 2. It's 5 less than 5. So here now the 1 will not be added to 8. So now here x will be equal to 3.62, our first answer, and here x will be equal to 1.38. 3.62 and other is 1.38. Please pause the video, students, and do it. Students, in this video we'll be learning about significant figures. Believe me, you'll find that after this video it's so simple to figure out what are significant figures. I'll just give you 2 golden rules. All non-zero numbers are significant. Okay? So whenever you come across with a non-zero number, it is considered as significant. Yes, it is considered as significant. Now, what are non-zero numbers? See, I have here on the board all this 1, 2, 3, 4, 5, 6, 7, 8, 9. Whenever they appear, they will be considered as significant figures. Now, throughout the video, to signify significant figures, I'll mark a capital S. So my capital S stands for significant figures. So wherever you see 1, 2, 3, 4, 5, 6, 7, 8, 9, any non-zero number, that digit will be considered as significant. Now what about this 0? Here comes the catch. So let's see, students, what we understand with this 0. Now students, with zeros, I'll say we can have 3 cases here. We can have 3 cases here. The first case will be zeros can be trapped within significant figures. Zeros can be trapped within significant figures. So I'll say first will be trapped zeros. Trapped zeros. Example for this trapped zeros is here. See, these 2 zeros are trapped between 2 significant figures 7 and 2. So whenever we have trapped zeros, students, that zeros are counted, that zeros are considered as significant figures. So I'll mark S over here. So one thing is done, that about zeros, whenever zeros are trapped between 2 significant figures, those zeros are counted as significant figures. So trapped zeros are always considered as significant. I wrote S. S means significant. Okay. Next, there can be the case, students, that we have, for example, leading zeros. Zeros can come at the leading position. Leading zeros. Leading zeros. Now the examples for leading zeros is, student, over here. Please see this. 0.0009. We have zeros which leads over here. So always remember this fact, students. Whenever you have leading zeros, zeros ahead of non-zero digits, zero ahead of non-zero digits, then those zeros are considered as non-significant. NS I'll write. I repeat again, whenever we have leading zeros, zeros ahead of a non-zero number, leading zeros. Over here also we can see this, two zeros are leading zeros. So these leading zeros are never counted in significant figures. So leading zeros are called as non-significant figures or digits. And the third one, the important one. Trailing zeros. It can be the case that zeros are trailing, zeros coming at the end. So now, students, when zeros are coming at the end, there can be two possibilities. Just pay attention here. I am talking about zeros coming at the end. There are various examples on the board. Here 0 is coming at the end. Here 0 are coming at the end. Here 0 is coming at the end. Here 0 is coming at the end. So there are two possibilities. If in the given number, in the entire number, we have to see whether decimal point is present or absent. So if decimal point is present, we have one scenario, and if decimal point is not present, we have a different scenario. Once again, I am explaining you about the trailing zeros, the zeros coming at the end. For that, we need to have two conditions. If in the given number, in the complete number, if you have decimal point, if decimal point is there, so I have marked a tick mark over here. And if decimal point is not there, then we have different scenario. Okay, see here. If in a given number, we have trailing zeros, and in that number, we have decimal point, then those zeros which are trailing, which are coming at the end, in the number which consists of a decimal point, those zeros are considered as significant. So I'll write S. But in a number where we don't have decimal point and we have zeros at the end, trailing, those zeros are considered as non-significant. So after understanding this, students, let's solve this, all of you together. Okay, the first one on the board we have 0.05002. Can I say, students, these two zeros are leading zeros, and leading zeros are always non-significant. So these two zeros will not be considered. These two zeros are trapped between 5 and 2. 5 and 2 are significant. And these two zeros are trapped. So these two zeros will be counted. So here the significant figures will be only 4. I'll write 4 here. Okay. So if somebody asks you, write your answer up to 4 significant figures, so you have to write up till here. This should be your answer. Okay. Here we have 4 significant figures. Okay. Next, 0.00230. Now, students, I see here these 3 zeros are leading zeros. Leading zeros are non-significant. Okay, but I can see one of the zero here, trailing zero. The last, after 2 and 3, we have a trailing zero. And then we need to see whether we have decimal point or we don't have. But here we have decimal point. So that trailing zero will be considered as significant. So this zero will be counted. So 1, 2 and 3. Here we have only 3 significant figures. Next, I have 9.00000. Now, students, see here carefully. Here we have trailing zeros. So trailing zeros we should always see that we have decimal point or we don't have. Here we have decimal point. So now all the trailing zeros will be counted as significant figures. So including 9, 1, 2, 3, 4, 5, 6. So here we have 6 significant figures. 720. 7 and 2 are of course significant figures. 0, it's a trailing 0 coming at the end. So we have to see whether we have decimal point or we don't have decimal point. Here the decimal point is not given to us. So when decimal point is not given to us, then the trailing 0 is considered as non-significant. So here this 0 will not be considered as significant. So here we will have only 2 significant figures. Okay, 720 has only 2 significant figures, 7 and 2. 69.00. 69.00, here we have trailing zeros and we have decimal point also, so it will be counted. So it will be 4. 302, here 0 is trapped between 2 significant figures, 3 and 2. Okay, and trapped zeros are always considered as significant. So here 3 significant figures. Here the 0 is at the end, it's a trailing 0 and we have decimal point, so it will be considered, it's significant. So 1, 2, 3, 4, 5, 6 significant figures. Here we have 0 at the leading point. Leading zeros are always non-significant, so this 0 will not be counted, but the trailing zeros are counted only when we have decimal point, and here we have decimal point, so this 0 will be counted. 1, 2, 3, 4, 5. So we have 5 significant figures here. Over here we have so many zeros and they are called as leading zeros, and leading zeros are always non-significant, so these will not be counted. Only 9 will be counted. We have 1 significant figure over here. Okay, and over here students, whenever we have anything at the power of 10 that is not considered as significant, always remember this 10 raised to 4, this will not be considered insignificant. 10 raised to minus 3 not will be considered. So we don't have to look anything about the powers of 10. Just see here, 3 and 1 both are significant, so here we have 2 significant figures. 5 and 2 both are significant, so 2 significant figures. And here, as we already saw, 2 zeros trapped between, so trapped zeros are always significant. So starting from 1, 2, 3, 4, 5, we have 5 significant figures. And one more thing students, when one quantity, for example if I take kgs, is converted into grams, so number of significant figures remains always same. Okay, please pause the video and solve it students. We are discussing now about nature of roots. Okay, how to find nature of roots? To find nature of roots we have a shortcut, a beautiful thing. To find nature of roots we need to find discriminant. Discriminant. Now what is this terminology discriminant? First of all, let me tell you, this word discriminant no need to write anytime in your exam. It is denoted by a Greek alphabet delta. It's not a triangle, it's a delta. So delta symbolizes discriminant. Okay, so I repeat once again, the value of discriminant, the delta, decides the nature of roots. Okay, so now let's see how value of discriminant decides the nature of roots. The very first thing will be, you need to find discriminant. And how to find discriminant? The formula of finding discriminant is b square minus 4ac. Now I know you all must be knowing it, that from where I got b. Any general equation of quadratic is ax square plus bx plus c equal to 0. So a is coefficient of x square, b is coefficient of x, and c is the constant term. From here we compare a normal quadratic equation and we get the values of a, b and c. Okay, so the first step is we find the value of discriminant known as delta with this formula b square minus 4ac, and depending upon our value of discriminant, our value of b square minus 4ac, we decide the nature of roots. Okay, so let's start with a discussion. The value of b square minus 4ac can be of 3 types. Can be of 3 types students. Okay, let's see here. B square minus 4ac, which is called as discriminant or delta, symbolized by delta, can have 3 different values or can be categorized into three types: first, second, and third. The first one, I'll say, it can be the case, I'm using the word can, it can be the case that you find the value of b square minus 4ac and you got an answer which is greater than 0. You find the value of b square minus 4ac and you get an answer greater than 0. That means, what do you mean by greater than 0? Greater than 0 means कोई भी positive value, any positive value greater than 0. It should not be 0. This is the first case. Or students, or I say it can be the case that you find out the value of b square minus 4ac and your value comes to be less than 0. What do you mean by less than 0? Less than 0 means that whatever value you got is negative. Negative values are called as less than 0. Or there can be a scenario that you found out the value of b square minus 4ac and it comes to be equal to 0. Now this is very easy to understand. Equal to 0 means value 0 आएगी, that's it. Okay. Equal to 0 means that value will be 0. So pay attention. Nature of roots depends upon the value of discriminant. And how to find discriminant? The formula is b square minus 4ac. There can be three possibilities that b square minus 4ac की value can be greater than 0, positive, less than 0, negative, or it can be 0. Now pay attention very carefully now. Very important part. If at all the value of b square minus 4ac is greater than 0, then we say the roots of a given quadratic equation are real and unequal. Roots are real. Real means they are real numbers, and unequal. The whatever two roots you will get, of course you will get maximum two roots because quadratic equation has highest degree 2. So maximum two roots are possible. Both the roots will be unequal. Same nahi hoge, and they will be real numbers. Okay, this is the hard and fast rule we are giving you. So based upon the value of discriminant only, we can decide the nature of the roots, that the roots will be real and unequal. Okay. Now comes the second part. If at all the value of b square minus 4ac is any negative number, which we call it as less than 0, then we say roots are imaginary. Roots are imaginary. And imaginary roots are not there in your syllabus. So we write no real roots. Don't say no roots. No real roots. There will be roots, imaginary roots. And it leads to complex numbers which we will study in 11th and 12th standard. Okay. Now comes the third case, students. The third case. It can be the case that value of b square minus 4ac is equal to 0. So here we will say roots are real and equal. The two roots which we will get, both will be equal and they will be the real numbers. Okay, students. Okay. So now let's once again summarize. B square minus 4ac की value, if it is greater than 0 or positive, that means roots are real and unequal. If it's negative, roots are imaginary, that is no real roots. And if 0, that means roots are real and equal. Real and equal. Here we wrote unequal. After learning about the nature of roots, that b square minus 4ac when greater than 0, roots are real and unequal. B square minus 4ac less than 0, no real roots. B square minus 4ac equal to 0, roots are real and equal. With that knowledge, let's quickly go over here. Find the nature of roots without solving. We need to find the nature of roots based on the previous note without solving it. Okay, we have the first question on the board. How will we start? Comparing with ax square plus bx plus c equal to 0. x square plus 2 root 3x minus 9 equal to 0. Comparing with ax square plus bx plus c equal to 0. So can I say, students, therefore a is here, there is nothing along with x square, so it's 1. So a will be 1. What will be the value of b? Be careful over here. Along with x we have 2 root 3, so I'll write here 2 root 3. And what will be the value of c? C will be minus 9. Yes. Let's find the discriminant, which is known as delta. Formula is b square minus 4ac. What's the value of b? B is 2 root 3. So 2 root 3 the whole square, minus as it is minus, 4 as it is 4. A, the value of a is 1. So a is 1. Value of c is minus 9. Okay, is equal to, this is 2 root 3 square. So it will be 2 ka square as well as root 3 ka square. 2 ka square is 4. Root 3 ka square is 3. 4 3s are, it's 12. Minus is 2 times, so minus minus becomes plus. 4 9s are 36. It comes to 2 plus 6 8. 3 plus 1 4. It comes to 48. And 48, students, what is this 48? 48 is greater than 0. We got a positive value. So what we can comment about the nature of the roots of this given quadratic? Therefore, roots are real and unequal. Okay, now let's solve the next question. The next question is on the board, students. X square minus 30x plus 225 equal to 0. We need to comment upon the nature of the roots. The first thing will be same. Comparing with ax square plus bx plus c equals to 0. So a, here a is 1 because along with x square we have nothing. So we always have 1. B is the coefficient of x, which is minus 30. And c is this plus 225. So after writing the value of a, b and c, let's find out the discriminant. Discriminant, which is known as b square minus 4ac. Okay, b square. b is minus 30. So minus 30 ka square. Minus, so here minus 4, so here 4. A, value of a is 1. C, value of c is 225 within the bracket. Okay, minus 30 square, even power on negative number, so it will become positive. 3 ka square is 9 and 2 zeros. This is 900. Only one minus it is, so I'll write only one minus over here. Okay, 4 5s are 20, carry 2. 4 2s are 8, 9 10, carry 1. 4 2s are 8 plus 1 9. So 900 minus 900, it comes to 0. So students, just now we got the value of our discriminant b square minus 4ac ka value. We got it as equal to 0. Therefore, roots are real and this time equal. Hope you understood, students.